So, Rosemary, I don't think we've met up since you were made a Fellow of the Royal Academy of Engineering. Congratulations, that's super exciting.
Thank you. I still get to keep my day job at Altair, but yeah, super excited about doing some work with the Academy as well.
Cool, so Altair, tell me, what does Altair do?
So Altair sits at the convergence of simulation, machine learning and high performance computing. So that means that we have got a very wide portfolio of simulation products for designing cars, aeroplanes, and a million everyday products around us. A lot of that is evolving with machine learning. We're introducing a lot of digital twin in order to do longevity analysis and quality analysis of products. And of course, all of that runs on supercomputing, which is where my team comes in.
So simulation, digital twins, that's all about predicting the future. So why quantum? Like, what's interesting about quantum to you?
So, I mean, simulation, yeah, as you say, it is about predicting the future, and we really can. Crash analysis is, just to pick one of the things we do, is extremely sophisticated. If we know the setup or the environment in which the event is taking place, we really can predict how a vehicle or a product will behave. So we obviously our customers do a lot of crash analysis and drop analysis, and that is absolutely key to making products safer and more durable. And one of my favorite products is actually called Squeak and Rattle. That product is why your Jaguar will go down the M25 in a silent glide. Absolutely incredible engineering that just wouldn't be possible without those simulation tools. So given that we can do all of that, why do we need quantum? Well, quantum lets us predict the future at a molecular level that is incredibly difficult today. The algorithms for doing physics analysis, they're very good, but they just can't scale in the way that quantum would allow us to. So if you want to simulate a molecule in a fluid or interacting with a surface, for example, so the sort of thing you would need for drug discovery or surface technology or even battery design, you can do that today, but it's relatively limited. And you want to be able to simulate more sophisticated environments, and you want to be able to simulate for much longer as well.
I mean, it sounds like one of the things Altair does is help your customers use different types of compute. So you mentioned AI, you mentioned CPUs and large scale computing. I mean, how do you see quantum fitting into that?
So we already support a wide range of different platforms. We already support GPUs alongside CPUs. We support different CPU architectures, and we're seeing really an explosion in the number of different types of accelerators you can have. So people are bringing out inference chips. GPUs themselves are getting more complex. People are bringing out SoC or system on chip architectures, mixing different CPU and GPU designs on one device. And of course, in the semiconductor space, people use hardware emulators that are very expensive, very sophisticated devices for accelerating hardware emulation. And quantum computing really, it's a little different from those architectures, but it does sort of fit into that space of compute accelerators where you've got a mix of HPC and something else, and part of the workflow runs on one architecture, part of the workflow runs on another. You've got traditional compute and machine learning in the mixes as well. And so I think quantum computing for the high performance computing industry is not too scary.
Yeah, that's super interesting. I think there's a lot that the quantum computing ecosystem can learn from the HPC ecosystem. So Altair invested in Riverlane. I was interested in why. What was the motivation behind it?
Quantum computing is really important for Altair because of the acceleration in physics simulation that would benefit many of our customers alongside the tools we already have. For us, Riverlane is solving an incredibly difficult problem. It's a problem that is very key to unlocking the potential of quantum computing. So as you work on error correction, all quantum computers are going to have error correction. And so for us, by investing in Riverlane rather than a specific quantum technology, we are making a bet really across the entire industry.
And what do you think Riverlane could learn from Altair?
Well, Altair is, we're experts in making sure that the right workload runs in the right place at the right time, and that's incredibly important for high performance computing, and it's going to be incredibly important for quantum computing as well. So our customers invest very heavily in expensive hardware, expensive software, and making sure that you're using those assets appropriately is a very complicated problem, and one that we are experts at solving. So no two HPC systems are the same, and I think that's going to be true of quantum computing. Even if there is a quantum technology that ends up winning, for example, if we all end up buying optical quantum computers, and even if there is one manufacturer that wins overall, still the use of that quantum computer is going to be different for each customer, because it's got to align with the business needs. If you're spending that much on the accelerator, then you've got to make sure that you're getting a good return on investment, and there will be multiple stakeholders in that decision-making process. And so making sure that the way you orchestrate the workloads, making sure that the way you assign budget and the way you track budget aligns with all of those business needs and all of the requirements of those stakeholders is really important, and just as important as actually making sure that the quantum computer works.
Yes, yeah, totally. We've got to bring quantum computing to customers, right? And yeah, brilliant, absolutely. Yeah, I mean, really excited to learn and go on that journey together. So thank you, Rosemary. It's been great chatting, and I would say cheers.
Cheers.